Welcome back, everyone, to Space Connect Space Show. Today's episode, we discuss risks and reward of a new era of commercial spaceflight. July 2021 marked the historic beginnings of crewed commercial spaceflight with billionaires Sir Richard Branson and Mr. Jeff Bezos and crewmates flying to the edge of space. Bezos' flight is also notable for the first paying passenger, the youngest and oldest people ever to take a space flight. But when ordinary people start to fly from the medical perspective, it becomes an issue of risk assessment and mitigation through preparation and training. Space travel is life-enhancing, and anything that's life-enhancing is worth doing. It makes you want to live forever. End of quote, Ray Bradbury. Welcome, everyone, once again to episode 48. When the show is over, Dr. Mindy Howard of Inner Space Training, Dr. Dorrit Donovan, the Executive Director of Translational Research Institute for Space Health at Baylor College of Medicine, and Dr. Rowena Christiansen from Australia, and also an UNOSA Space for Women mentor, will take your questions. And we'll invite you to put any questions in the comment section below this post. Now we have a big agenda. We will present examples on the risk and the rewards of space tourism, human health on space missions and its implication on health on Earth, as well as how to prepare to take a commercial space flight. So once again, thank you for your participation, and we're looking forward to an exciting episode today. Now, without further ado, let me introduce you to Dr. Rowena Christiansen. She is a space show team member, first of all, for almost a year, I believe, and it's also her first year here as a UNOSA Space for Women mentor. She is an Australian physician practicing in pre-hospital emergency care and medicine in extreme and austere environments with a focus on space health. She teaches human physiology and clinical practice with the University of Melbourne Medical School. So I'll hand the mic straight to you, Dr. Rowena.
Thank you very much for your kind introduction. I really appreciate it, and also the opportunity to speak today. And I guess a lot of people like me on this call have probably dreamt of becoming an astronaut at some stage in your life, and perhaps we thought we would never have the opportunity to experience that, but space tourism or commercial spaceflight is potentially an opportunity for ordinary people to go to the edge of space. And it sounds very glamorous and super cool, but at the same time, we do need to be cognizant of safety concerns. And at the moment, it's a bit like the Wild West of yore, that there's some tension between entrepreneurship and regulation. There is some potential for mass casualty incidents in the air and on the ground. And at the individual level, we have to consider the potential human cost and balance the desire to fly with the question of whether somebody should fly. So I'm going to start with the good stuff and just quickly go through a number of the options. So first of all, there's parabolic flights. You may have all heard of the NASA so-called vomit comet, but it's not actually as bad as that. Only about 10% of participants end up getting sick, which is great to hear. And it's probably the cheapest alternative. It's only about 6,000 euros. There are a couple of other high altitude options, about 30 kilometers up. That's one high altitude balloon schematic. And this one, from space perspective, looks as if it's actually going to happen, and you would end up floating at the edge of space or being able to see the edge of space for about 2 hours. And the ticket cost is currently US $125,000. and they're already sold out for 2024. There are also various proposals for hypersonic aircraft. They will fly at about the same altitude, and the partly constructed NASA X-59 is in the image there on your screen. And potentially it would allow people to cross the Atlantic Ocean in just 2 hours and the Pacific in 3. And you would still be able to see the Earth's curvature and the blackness of space above. And it's worthwhile just noting that although about 100 kilometres is technically the edge of space, the air's far too thin up there for a conventional aircraft. I'm sure just about everyone on the planet has heard of Virgin Galactic, and of course they had a successful first crewed flight on the 11th of July. And once commercial flights begin, people will be able to fly to up to 110 kilometres in altitude, have about 5 minutes of zero gravity weightlessness, plus a view of the curved Earth below. There will be some G-forces on the way up, but a dynamic glide on the way down. And I read just about a week or so ago that they are going to resume sales and revenue flights in 2022, and the cost will start at $450,000 US. The other option is Blue Origin, and of course they're in fierce competition with Virgin Galactic, and I was interested to find on the Blue Origin website this image here comparing the two and how Blue Origin is much more environmentally friendly. So that one's a little bit different. It's capsule for 6 people. There's no pilot. You get about a 10-minute flight with about 3 Gs on the way up and maybe about 4 Gs on the way down. And once again, a few minutes of weightlessness. And at the moment, there's no information available about the current cost of a seat. Interesting question of who ends up getting commercial astronaut wings. And the same day that Jeff Bezos took his flight, the FAA in the US actually released this latest advisory. And it said that you have to fly beyond 80.5 kilometres. And during flight, you need to demonstrate activities that were essential to public safety or contributed to human spaceflight safety. So that does raise the question of whether people who are essentially just going on a joy flight or space tourism will end up being entitled to astronaut wings. I'm sure everyone has heard about the Inspiration 4 3-day orbital mission, which is launching in September to orbit the Earth for 3 days. And I know that Dorit is going to say more about that during her presentation. And interestingly, back in 2019, NASA opened up the ISS to commercial visits and allowing a couple of private astronaut missions each year. And those were to use the vehicles developed under the NASA's commercial crew program, such as the one that SpaceX has been using in recent times. It's also going to be quite expensive, about US $35,000 a night for each passenger on top of the charge for the flights. Whoops. And Axiom Space has actually gathered together the people for the first private mission to the ISS, which is going to happen in January 2022. And I did find in an article a reference saying that seat cost was $55 million each. So not cheap. Russia has a long history of offering opportunities for people to go to the International Space Station, flying on the Soyuz rockets and vehicles. And a company called Space Adventures has organised all of these trips to date. The price tag is between $20 and $40 million. And at the moment, they're offering an opportunity for 2 private astronauts to go to the ISS in 2023. And one lucky person will get to go for a spacewalk. There are a number of proposals for space stations, but perhaps the Axiom proposal is the most advanced. They've actually started building theirs. And a bit of a wild card is China's space station, the Tiangong. And I did read that they are proposing to accept astronaut visits from people of other nations. So I think that's going to be a bit of a watch this space. Of course, it's only the first module under construction at the moment. There may be space hotels in the future. I've read about a few proposals, but there doesn't seem to be a great deal happening in that space at the moment, but I dare say it will come. And I really love this proposal from the Gateway Foundation to build the Von Braun space station, which they are designing to have artificial gravity similar to the moon, which is 1/6 of the Earth. And if you remember the beautiful rotating space station from 2001, A Space Odyssey, this would be a similar idea. So now I'm going to talk a little bit about the risks. And of course, human spaceflight is like any type of exploration that's pushing the boundaries, and there's always going to be the potential for disaster. And in fact, there have been a number of quite significant disasters over the history of the space program, both prior to the Apollo program and consequent to that. And the most recent one was the crash of one of the Virgin Galactic prototypes back in 2014. Fortunately, human spaceflight is not quite as risky as you might think. And if you look at the odds of dying in a motor vehicle crash at 0.88%, and you look at the risk of a total catastrophic failure at 1.33%, it's not a great deal of difference, but it is worth noting that air travel is much, much safer than either of those. There are many spaceports all around the world, and I have read that there are a number of additional proposals for spaceports to be built. So this is a growing industry, and we're likely to see more and more of these in the coming years. They'll be busy places. There'll be a lot of people within a focused geographical area. There'll be employees and people who've come to watch, much the same as when I was a child. We used to go to the airport to watch planes take off and land. And the same as at airports, there'll be large quantities of flammable fuel and other chemicals. So there's going to be an ongoing risk of mass casualty incidents resulting from this combination of rocketry, fuel, spacecraft, and mass gatherings. It's going to be really important that spaceports have robust emergency management plans, and I would expect that most of them will be located in remote areas that are far from major hospitals and trauma centres. So there's going to need to be a good medical plan for what happens if something goes wrong. So now I'm going to move on to the actual space flight itself. And there are a number of aspects to making it safe. The first is spacecraft design. The spacecraft has to be able to manage the G-forces on takeoff and landing. It also has to be able to cope with the extreme environment outside, where it's very high altitude, very low atmospheric pressure, extremely cold, and a virtual absence of oxygen. We need highly trained space pilots, and astronauts, of course, typically spend many years training for a mission. So we would hope that our space pilots had also been through a long apprenticeship. And then moving on to the passengers. Passengers themselves will need to be suitably trained, attired, and protected from the environment. And perhaps from the medical perspective, the most important thing is that people need to be capable of coping with both the anxiety and psychological stress of spaceflight, in addition to the physiological stresses such as increased G-forces. And training is going to be incredibly important, and Dr. Mindy is going to be saying a little bit more about that in a little while. And it's interesting that at the moment, the US FAA requirements are fairly minimalistic, that people just need to be trained how to respond to emergency situations. And the provisions about informing people of the risk is actually a lot more extensive. If we have a look at what training will be provided, Virgin Galactic at present is saying they'll be offering a 3-day pre-flight training program. And for the recent actual Blue Origin flight, they had 2 days of comprehensive training, which was designed to be compliant with the FAA requirements. There is private training available, for instance, at the NASTAR Center in the USA, which offers training for both suborbital and orbital spaceflight. These courses are all 1 to 2 days and include simulator and centrifuge training. And if you do the advanced course, you also get to do some altitude chamber training. But people do need a medical certificate and to be in good health in order to take part in these. Something that I'm really looking forward to, and I know that Dr. Mindy is involved with, is the Blue Abyss Commercial Space Training Center, which is anticipated to open in the UK in 2023. And that will be a sort of one-stop shop for commercial spaceflight training and also for professional astronauts and people in the diving industry. And just a little spoiler of what we might be hearing about very shortly. And if you look at parabolic flights, there are some requirements in terms of whether people are medically fit or not. You need to be able to climb a couple of flights of stairs without being out of breath, and you need to be in good health. And there are some illnesses that exclude people automatically, for instance, serious heart disease or serious asthma, dizziness, and you can understand why that would be so. Neurological problems like epilepsy, where people might have a seizure, and some anxiety-related conditions, pregnancy for obvious reasons, and certain medications. There's actually a very comprehensive medical document that needs to be completed, and people need to attend a doctor to have a full medical and an ECG before they can take a parabolic flight. And then if we're thinking about who should actually be a space tourist, so on the one hand, we know that astronauts have to be only the fittest and healthiest of people. But there have been a number of recommendations and guidelines about medical assessment of commercial spaceflight participants, which have been published since about the year 2001. And requirements may vary between spaceflight providers, but you would have to assume that similar to the parabolic flights, people will need to visit a doctor trained in aerospace medicine for a pre-flight medical and to have a favourable assessment of their response to pre-flight training. And that would have to be both the physical or physiological and the psychological response. The FAA guidelines distinguish between suborbital and orbital flights depending on the degree of G-forces that people will be exposed to. But if the load profile could exceed 3G, then the orbital guidelines apply. And I would certainly argue that that would apply to Virgin Galactic and Blue Origin flights. And the FAA also has quite a comprehensive list of medical conditions which are contraindications. So as a result, people with pre-existing conditions won't necessarily be excluded, but they have to be able to handle themselves safely in an emergency. And one wild card is there's no way of knowing who will develop space motion sickness when exposed to microgravity. And that's because the vestibular system in our inner ears becomes disoriented when it loses its familiar inputs. So this is something that both spaceflight participants and the spaceflight organisers need to be aware of. And to have a plan to deal with that or minimize the likelihood that it's going to inconvenience other passengers. So there are a lot of unknowns. There's not a lot of data at this point, and we're going to need to collect a lot of data on actual flight participants before we can come to some really solid conclusions. However, there have been a number of small studies commissioned by the FAA to look at the ability of ordinary people to tolerate the equivalent of a suborbital flight by placing them in a centrifuge. And it's been very heartening to see that people from 19 to 89 years with a large variety of common stable medical conditions were able to tolerate this without too much difficulty. However, thinking about the psychological part, 6% did have to stop the centrifuge exposure because of anxiety or motion sickness, and a number developed unsafe or potentially problematic behaviours. An article on a systematic review of medical guidelines for suborbital commercial spaceflight has come out very recently, and it essentially follows the same conclusions that I've mentioned already. It also recommends data monitoring of spaceflight participants and having some capacity for basic in-flight care for medical emergencies. So in conclusion, a lot of additional dialogue is needed about medical screening and training guidelines for commercial spaceflight, and we're going to need this to be informed by experience and data collection. There is always going to be a potential for disaster. We can't completely get rid of that risk. And there's the macro risk of large-scale disasters. So you need robust risk mitigation and response strategies. And there's also the risk of adverse events or even death occurring to spaceflight participants. And that falls on individuals and their loved ones. And I'm sure that if that ever did happen, there would also be commercial fallout for the industry as a whole. So risk is something we never should be or can be complacent about. And to quote the Spanish philosopher George Santayana, those who cannot remember the past are condemned to repeat it. Thank you very much.
Thank you, Dr. Rowena, for this great presentation. I'm curious, if you got a ticket, would you go as a scientist or would you go as a tourist?
I'd rather go as a scientist because for me, ever since I've been young, the idea of going to space has been to do something beneficial to help humanity. So I'm sort of very passionate about that idea.
Great. I think I started the application at ESA, and I think I changed my mind. I'll go as a tourist. It's a one-time experience. So anyway, thank you so much, Rowena. Our next speaker, esteemed speaker, is Dr. Dorrit Donoviel. She is the Executive Director for Translational Research Institute for Space Health. And she leads a $0.25 billion NASA-funded innovation research and R&D program that finds, funds, and facilitates disruptive human health and performance solution for astronauts traveling in deep space. In her previous role as Deputy Chief Scientist of the National Space Biomedical Research Institute, Dr. Donoviel led both domestic and international research programs that bridged academic, industry, and government resources to deliver fast and cost-effective tangible results. She's the recipient of multiple honors from NASA and a recipient of the NSBR Pioneer Award. Dr. Donoviel authors scientific articles in academic journals as well as the popular press. She speaks about space health concerns and innovative approaches to investing in science and medicine at domestic and international conferences. We couldn't ask for anyone more qualified than you to speak on to speak on the implications on health on Earth, human health on space missions, and its implication on health on Earth. The floor is yours.
And thank you so much for this invitation. And it's so much fun to be up at 5 o'clock in the morning, Houston time, talking with wonderful ladies about space for women. This is so fun, and I'm just excited to be here. So I am going to talk about human health on space missions near and far, and what this means for implications for here on Earth. I'll be honest with you, I have a lot of friends who don't quite get it. Why are these billionaires spending their billions of dollars going to space? You heard about the ticket prices from Dr. Rowena, and that was an amazing presentation. And I'm so excited that you and I are now connecting through this event because we can talk more about it. So our job at TRISH, that's our favorite acronym, our institute name is way too long to remember. We actually are partnered with NASA. We're funded directly by NASA. And our job is really to extend the reach of the agency into communities that normally would not be even thinking about engaging with the space program. And a lot of people don't understand the incredible value of going to space for the human body brings to human health, because space is such a unique environment for the human body. And I'll talk a little bit more about that in a minute. But our institute is partnered with the space agency, with NASA. It is a consortium that is run out of Baylor College of Medicine. That is my employer. I'm a faculty at Baylor. And we're partnered with two very amazing institutions across the nation, Caltech and MIT. Our job is to go out there and find all kinds of innovative solutions that the space agency itself doesn't know about in terms of human health and how to keep humans healthy in space. So NASA is advancing, making steady progress in reducing the risks to humans in space. Their job is, while we figured out in low Earth orbit how to keep humans safe, humans have been living on the space station for the last 20 years. We have figured it out. Those humans are coming back relatively healthy, in fact, very healthy. But as we think about going beyond low Earth orbit into deep space, that is the concern that NASA has in mind. We have to figure out how to keep those humans healthy. But because there's now a burgeoning new industry around regular people going into low Earth orbit, TRISH is now getting into the business of seeing whether we can learn from some of those individuals going into space now to advance our knowledge about humanity going into deep space. So NASA in particular has asked TRISH to make those investments in things that are more disruptive, things that are perhaps a little bit out of the box, if you will. For example, very recently, we solicited for proposals to actually put people into hibernation. So you're going to be seeing some very interesting things coming out of TRISH. And those are those giant leaps that we're going to need in order to take humanity into deep space beyond our low Earth orbit. So what do I mean by that? So the Artemis program really is something that takes us back to the moon. It's been far too long since we've been to the moon, and we're absolutely committed to put some female boot prints up on the moon's surface. Everybody's probably seen the recent news saying that NASA may not be ready by 2024 with the spacesuits and all of that, but we are absolutely going to go back to the moon before the 2020s are over. So the needs are really, when we leave low Earth orbit, the concerns with regards to radiation become more acute. We are no longer protected by our atmosphere. And in the 2020s, when we are operating in the lunar vicinity, the return back to Earth, if there is a medical emergency, is no longer just a matter of 9 hours, leaving the space station and coming straight back to Earth, but now a matter of days. So medical emergencies become much more of a concern. When we leave the lunar vicinity, the plan is when we do go to Mars, for example, in the 2030s, now you're talking about a whole different paradigm of having to provide everything that the crew will need, because there will be absolutely no ability to resupply them with food, medications, or anything else. So now we have to think about a whole new model of providing a capability to keep those humans healthy. So what we're focused on right now is transitioning humanity from low Earth orbit into the moon vicinity and then go beyond to Mars. So why is space exploration difficult for humans? Dr. Rowena did a fabulous job talking about the burgeoning ecosystem that's happening with commercial spaceflight, but that's still within low Earth orbit. What we're focused about is really about those deep space destinations. And the isolation is really quite a major concern in terms of behavioral health. And Dr. Mindy will be speaking more about the behavioral health concerns as well. We've all been socially isolated for the last several months at home. And so we got a little bit of a glimpse of what that's like. But imagine not being able to open a window or go outside for a very long time. A mission to Mars has been estimated with current propulsion capabilities to be anywhere between 2 years to 3 years. That's a really long time. The gravitational fields. So we have figured out how to live and stay healthy in zero gravity, but there are some medical concerns, including a new ocular syndrome that has been described in the last 10 years, where we're seeing some changes in the pressure on the brain that could be impacting on the vision of the astronauts. Gravitational fields are a concern, and unfortunately, we haven't quite figured out the artificial gravity. Like, we could probably do it in a small scale, but certainly not those rotating vessels like we see in a lot of sci-fi movies. A hostile enclosed environment. Figuring out how to make sure that the carbon dioxide that we exhale, just normal breathing, doesn't accumulate too much and affect the human in a negative way is not a trivial thing. And we have to make sure that the water supply remains safe, that we provide a real clean and safe environment for those humans. And that there's some technological hurdles to be overcome in terms of all of those habitat concerns. The distance from Earth means that if there's an emergency, we can't bring the crew back. So we have to absolutely empower them to be autonomous and to solve situations as they come up. And the further you get away from Earth, the more you're going to have a problem with lag in communication. So if you are relying on Earth to give you feedback in terms of how to solve your problem, it could be up to 40 minutes before you can get a reply to your question. So we have to actually enable the crew to be really kind of autonomous. Radiation, I already mentioned, is a major concern. There's space radiation, galactic cosmic rays in particular, that we really cannot shield for. So those humans will be exposed to radiation over a period of 2 to 3 years. It's low dose, but it's chronic. And so the concern is that they may develop some health problems over that mission. So we're developing capabilities to make those humans more resilient. Some of those things really apply for Earth because it's a prevention of the cancers. It's a prevention of the heart disease that can be exacerbated by the radiation fields. It's not about fixing a cancer that's already existing, but it's a very different model of healthcare that really kind of tracks the human and makes sure that they're not developing disease states. So this slide, I know, is very busy. I just want to show you that every single organ system is affected by a trip to space. Everything is affected. And over the last several decades, we've been studying a very small group of humans, try to understand all of those changes. And what's so important and interesting about this is that in space, the transition from being a healthy, well-screened, well-trained in terms of physical and mental resilience to a spaceflight environment that's incredibly harsh is so fast that we are able to study the changes from being healthy to a pre-disease state, if you will, or maybe even an accelerated aging model, and then back to Earth, the transition back to a gravitational field again. We're seeing the reversing of some of those changes. It's such an interesting model for me as a biologist or a person who's studying human physiology. Those rapid transitions with the space environment are so interesting because we can look at things that would normally take a decade to develop in a regular human here on Earth in these individuals. And so it's an opportunity to understand physiology and biology in a whole new way. So I mentioned the fact that for the last 60 years or so, since we've been exploring space, there's been roughly 500 humans who have gone to space. As we all know, we are becoming a lot more diverse. So at least NASA's class of new astronauts have included a much more diverse pool of participants, people of color, more women, and that's fantastic. But over the past, it's been largely a lot of white men who have been very, very carefully screened. And there was a reason for that. They came from the military. A lot of them had to be pilots, and that tended to attract a certain demographic. But as you can see here, very few of them have been people of color or other types of demographics. And so what we're excited about is that the future is looking very different. And this is a study that was published by the Harvard Business Review. So currently in 2021, 88% of the people who have gone to space have been professional astronauts, very well screened, very well trained. But what we're seeing is a complete flip over the next 20 years, where 80% of the people who will go to space will actually be very different demographic. And so we have to address this. We have to make sure, as Dr. Rowena and Dr. Mindy have talked to you about it and we'll be talking about it, we have to make sure that all these individuals are safe and healthy when they go to space and come back. And we have to take advantage of the opportunity to study these individuals because we're going to learn some very important things about human physiology. So the new space, these are just a handful. And I was so excited when Dr. Rowena was showing her slide deck. It's like furiously writing notes about all these other companies that I knew nothing about. But the ones that we have on our horizon that we're talking to right now about engaging their passengers are these right here. And we've made some headway with one, and we're in discussions with the rest. And so you'll hear more about that. You'll hear more from me today about SpaceX and more from me in the future, if you have me back to your space show again, about some of these others. So in particular, Dr. Rowena already mentioned on September 15th, in just 3 weeks' time, SpaceX is going to launch the very first all-commercial crew. This has not been done before into orbital space. So yes, Virgin Galactic and Blue Origin have gone to space and done a short flights in suborbital. That means that they were not orbiting the Earth. This will be the very first orbital flight that will go around the Earth about 2 to 3 days. And they're completely autonomous. They are not connected to the International Space Station. This is not a government-sponsored program at all. This is a first orbital flight that's completely private. And we are so excited to have had the relationships with SpaceX, and their medical director, Dr. Anil Menon, came to us and said, our crew really wants to participate in research. And so being a NASA-funded agency, able to work very nimbly, we were able to put together a suite of research projects that made sense. So let me tell you a little bit about what's happening. We jumped at the opportunity. We selected things that are important for Artemis, for the agency. We're concerned about radiation, we're concerned about medical capabilities, we're concerned about behavior and the G transitions. And all of those actually make sense for this short duration mission. This is just a 2 to 3 day flight. It is not several days, it is not several weeks, it is not even months like many of the astronauts that go to space. So for example, bone and muscle and heart changes really require more than just 2 or 3 days in space. So we're not going to be looking at those. But we wanted to look at things that make sense for an Artemis mission. This is very much like an early Artemis mission. It's a small crew in a small vehicle orbiting like the moon around the Earth for a few days. And so let's see what we can do. The other thing is that, remember, these are private people. They really don't want to be engaging in really complicated experiments. They're wanting to enjoy their flight. So we had to give them things that were easy to use, minimally invasive. Nobody wants to be taking a lot of blood samples in space or collecting stool samples in space. And also the training time, we want to make sure that these were easy. So we assembled a suite of things that we provided to SpaceX and said, okay, these are the possibilities that make sense for Artemis, that make sense for this crew, that makes sense for this duration of a mission. What do they want to do? And so they came back to us. And also SpaceX itself has certain restrictions with their capsule. So for example, the capsule itself is not necessarily set up to stream back data in real time. Maybe there's a limitation around power that needs to power certain devices. And so we had to work with the SpaceX engineers to make a suite of products or experiments that actually make sense with the infrastructure of the space vehicle. And we had to find researchers who are incredibly collaborative and willing to go back and forth and work with SpaceX to make this a success. So that was absolutely key. So we actually ended up with, this is sort of the down-selected group, if you will. I'm just going to give you a tasting of it. We're going to do in-flight blood and saliva analysis. Now, we're not going to be taking actual, blood for like a real blood sample. It's just going to be a small drop of blood. And there are capabilities that we've been funding over the past several years to do an in the moment blood analysis, similar to what you would get when you go to the doctor once a year and you do your health checkup, essentially. Saliva is easy to collect. They have no cold storage on board, so we really can't be collecting blood samples and storing them and bringing them back to Earth. And so that's one thing. But we are collecting some of the samples before and after flight. And the reason for doing that is we're looking for markers, for things that can tell us how people will do in flight. So how can we determine if somebody will do okay in flight or not? Or what can we learn about pre-flight, what we can learn about an individual, how they will adapt to a spaceflight environment. The miniaturized ultrasound device, the butterfly device, completely revolutionary. We sent this device to the ISS. Astronauts have now used it. It is incredibly miniaturized and highly capable for a non-expert user. Can do every single scan of every organ system, which is amazing, because right now ultrasound devices on the ISS and on Earth are large devices and require multiple probes. So this is revolutionary. We're sending the butterfly up on the Inspiration 4 flight. And in particular, we're interested in what happens to the blood flow from the neck region, the internal jugular vein that helps to drain the blood away from the head. Because I mentioned to you that there's some concern about pressure on the brain and pressure on the eyes. We're thinking that there might actually be a concern with drainage of blood. The concern for that is that if you have a problem with drainage of blood and your blood is actually pooling in the neck region, that is a risk for thrombosis, which is a blood clot, which could create a major problem. So this is something, it's an opportunity to study in these 4 individuals on this flight. Some other experiments that we're doing, they're going to be wearing an Apple Watch. And this was, again, negotiations with SpaceX. What do they want to fly in terms of monitoring their cardiac rhythm, their movement, their sleep, the blood oxygen saturation, even the light intensity, to understand how the cabin environment is affecting their sleep-wake cycle. All of those things really are important for their ability to do a job, the neurocognitive performance, your fitness for duty. So this is a battery of neurological tests that's on an iPad, which they'll be taking up. And it's one that's being used by astronauts right now. And it really looks at your fitness for duty. Are you able to perform at a high level cognitively? Now, if there's no emergency, okay, you can be sick and sleepy, nobody cares. But if there is an emergency, we want these people to be able to be alert and able to perform their jobs. So we're going to be assessing that as well. And then, as Dr. Ruido mentioned, the sensory motor adaptation, the balance problems, we're learning about how do people adapt to the G transitions, the zero gravity. Nobody wants these people to be sick. So are there things that we can do ahead of time to train them or predict who's going to get sick and give them the medications they need to make them feel better in flight? The reason you don't want to give medications to everybody is because those medications, some of you may have taken them when you go on a boat, can make you sleepy and you won't enjoy the ride, or you won't be able to perform in case of an emergency. So if you don't need to take a medication, let's predict that ahead of time and not have you be pre-medicating unnecessarily. So this is kind of a boring slide, but what's important here is that we're setting a whole new paradigm for research across all the providers. We're using the SpaceX flight as a test case. And IRB, for those of you who don't know, is an institutional review board. When you're doing human subject research in the US and in other nations as well, they have their own methods of ensuring protection of subjects, research subjects in Europe and in Australia and other places. But in the US, it is an IRB, and we make sure that everybody's safe. And so this is all done under the context of an umbrella IRB across all those research studies I just mentioned. Those are multiple universities from across the US. We have 6 universities involved, and they're all under one umbrella. We made it very simple, one consent form for everything. And we're putting everything into a database that will capture all this data and be made available freely to the research community. And we'll be able to cross-reference data sets, compare data sets, and look at conclusions when one compares, for example, heart rhythm with radiation and baby heart rhythm with blood analysis, or all kinds of things across the board. The other thing that we're setting this up for is that we're going to be able to take in international participants. And we're talking to the other providers. Over half what we're estimating of these private passengers will be internationals. So we have to be able to take those data sets in. Okay, so what we're putting into our Hermes database is not only the data from this flight as well as some future flights, but we'll also be taking in the medical data that some of these folks have generated in preparation for their flight. And I hope I didn't go over. I may have gone over. I apologize. With that, I'm going to stop, and I guess I'll hold questions till the end. Thank you so much.
Thank you, Dr. Dorrit. This was an amazing presentation. I think all of the space for health implication had been covered, and the reasons why space health is important and the relevancy on Earth. Our next speaker is Dr. Mindy. She's going to explain to us actually how we are going to get it done through her training. So Dr. Mindy Howard, she has passionately achieved her dream of going to space. After 20 years career in the oil industry, working in 35 different countries as a trainer, senior leader, and engineering advisor. She harnessed her academic program Inner Space Training, trains coaches and accompany commercial astronauts to space. She's working for Blue Abyss, the world's first commercial astronaut training center, as the director of Inner Space Training. She has appeared on the Discovery and Travel channels and on radio, both in the US and in Europe, as a space correspondent and commentator. She is also a lecturer at the International Space University and has authored a book called Blast Off, Train Like an Astronaut for Success on Earth. Now, tell us how we can get ready, Dr. Mindy.
Okay, I'll do that. I'm really happy to be here. Thanks for inviting me and to be in this incredible company of esteemed colleagues. It's great to be here. Yeah. Yes. All right. I didn't want to go and get into it in complete, talk about my background, but I just wanted to point out a couple of things in terms of who I am and why it's relevant for what we're talking about today. I have a human factors background, and that's going to be coming in this discussion in terms of this presentation and how I sort of look at things from that perspective. One of the things that I joined a group probably about 10 years ago that used to be called Astronauts for Hire, A4H. They are now called the Association of Spaceflight Professionals. And it was there that I actually got I did a lot of training and learned about commercial spaceflight training and how to prepare oneself and being on the training committee. I'll talk about some of those things that I experienced there, but I did, a number of different types of training programs, physical training programs, being exposed to in these sort of high pressure environments. In fact, this picture here is at the NASTAR Center, doing my centrifuge training. It was actually, I'm going to tell a little story about that in a second, but I just want to also point out that just recently I've joined the American Standards technical committees on spaceflight, let's say preparation, both medically and in terms of crew and spaceflight participant safety. So I want to talk about that as well. So this picture in the centrifuge, this was before I went into the centrifuge. Things, I was very excited, and I ended up, having this incredible experience, smiling from ear to ear, and I thought, wow, this is great. I mean, I did everything that they said that we should be doing in the training, and I felt like, oh, this wasn't too bad, and walked out, and we looked at the next person in the team or in the training that was taking the other people in my course, because we could see each other's faces as we were inside the centrifuge. And although I was smiling from ear to ear, there were some people who had a different look on their face, like, oh my God, what's happening? Eyes bugging out of their heads, turning several different shades of green because they were frightened. And I remember thinking, hey, that's kind of interesting. I wouldn't have expected that from this guy in our training who was like the Arnold Schwarzenegger of the group, and thinking, that's strange. I wouldn't have expected that. And he was frightened. And I remember asking at the training center, is there any training out there to help people sort of mentally stay calm and focused for their flight? Or was it only the physical training that they would get to feel what it's like to be, getting those 6Gs on them? And they said, no, that didn't exist. And I thought, okay, that was the inspiration of inner space training, because I really believe, and still do, that mental training is kind of like the thing that underpins every kind of training that you will be doing to prepare yourself for space flight. So that it all starts there. So let me move to the next slide about my experience in the last year or so as a member of this standards committee. And I was asked to join the committee because they said they didn't. One person in particular said, I don't think they're even talking about the psychological element of space flights. And I think you need to be there. And I was like, okay, that's a little bit disconcerting. What are they talking about? And so in this is actually sponsored by the FAA. This group, is basically coming up with standards for crew, for spaceflight participants, about what sort of minimum standards do these space operators need to have, both for the crew and for people going into space. And it was, and I remember thinking like, oh, this is interesting. Let's look at what some of those standards are. And I remember thinking, well, I haven't seen the words, psychological preparation in any of these things. And I thought that was a little bit strange. Like, is this not on people's radars yet? And then started to dig a little bit into, who's coming up with these standards, and why are there not like lots of standards as to what the minimum a spaceflight participant needs, or crew? And I was told that for the first sort of 8-9 years that this group has kind of been creating, or they've been existing together. The people in the committees are people from the FAA, Virgin Galactic, Blue Origin, Axiom Space, all the big names of spaceflight operators. And they are, they essentially said, we don't want to have tons of standards because, don't kill the industry with standards before it even starts. So, because we want to, we're trying to create a new industry here. and standards and regulations, will get in the way. So we want to take a minimalistic approach and not, impose standards on the spaceflight operators, because it's hard enough getting people to space. Never mind, putting others, really difficult standards on top of that people will not be able to comply with. So let's just see how it goes and take it from there. And I remember thinking like, what, really? And they explained to me and they said, well, it's like the airline industry where, people were in the 1950s, without seatbelts and smoking cigarettes in the back of the plane. And, that was the way they did it. And then over time, things evolved to, okay, maybe we should use seatbelts and maybe people shouldn't smoke, and regulations started coming into the industry. Maybe we should explain to people where emergency exits are and things like that. So that is the thinking of what is currently going on. At least for the spaceflight operators, like, let's not kill the industry with all of these standards. But I'm sort of been brought into the group and I'm thinking like, wow, I'm just, so surprised. And as I'm asking people in these companies or people who have bought tickets, like, can you tell me a little bit about what kind of training, what are those 3 days? So Dr. Rowena had mentioned that, 3-day trainings or 14-hour trainings, both with Blue Origin and Virgin Galactic. Like, what sort of training are we talking about? And I've essentially, sort of heard that they're, and I'll explain this in the next slide, but it's not the kind of training that I would consider training as an astronaut trainer. And it's really interesting how the word training can be completely interpreted in different ways depending on who's looking at it. Because if you're a space flight participant, you're buying a ticket and you hear, oh, everything is fine. Virgin Galactic has a 3-day training. So that should be good enough. So training is being taken care of. But when you start to dig a little deeper and find out the elements of what goes in that training, you start to think like, hey, is this going to be enough for people to, to make their trip safe and for them to accomplish their objectives in space? And Dr. Marina also, published a couple or talked about these medical studies that I started to dig into a little bit deeper when I've been sitting on the committee, because you have a new standard and then there's references at the end of the standard, which say, oh, where did we get, the information that we're putting in here is referenced somewhere else. And I found out about a lot of these standards that Virgin Galactic commissioned, and which essentially, kind of disproved, I think, the point that they originally wanted to prove when they started these studies, which is that actually training is helpful and necessary, but they don't want to actually to have for each ticket people buy training costs, like a proper training to be included. And I'm saying something I think which is fairly controversial, and you can only guess why that is the case. But if you can imagine that, training, what I'm talking about, which might be costing an extra $15,000-$20,000, is actually really what's necessary to ensure that people are safe and can accomplish their mission in space. It sounds like it's probably a commercial decision that these companies are taking, not to go and to say it's required, or at least not yet. We need to pass the 1950s with the smoking and the seatbelts, to get to a certain point, maybe when there's an accident or incidents that are happening, that I think that they will start to say like, maybe it's a good idea to do more than what we are actually saying needs to be done and what is actually happening in those 3 days before people fly. So in these studies, what I sort of read into in terms of like what were the studies about, and what the studies that I'm referring to are saying essentially that people, when they talk about training, in these studies, they're talking about essentially what I would call giving information as to what's going to be happening. So, the flight profile, first we're going to be taking off and launching, we're going to have weightlessness, re-entry, giving information kind of about what's happening, the emergency exit kind of training that you would, maybe hear in something similar to an airplane, and do some practices as to, different sort of simulated mission rehearsals in a safe classroom environment, or go into a mock-up of what the spacecraft is looking at. But that is essentially where it ends. You are not getting exposure in these 3 days before you fly to high G sort of like environments like a centrifuge, and feeling what it's like to get 3.5 Gs on launch and 6 Gs on reentry. And you're not going to feel like in a parabolic flight what it's like to go 0 G, and to learn how to navigate, weightlessness. And you will be exposed to that the first time when you're actually flying in space. And I find, I find it really interesting because when I was in the centrifuge, it's nothing like I've ever felt before here on Earth. Any roller coaster doesn't compare. And that feeling of, first of all, learning, that I'm being squished into my chair. And, for a lot of people who have a long neck, who are tall, they're actually starting to get feelings of like tunnel vision that they're going to need to learn how to do certain breathing exercises like the anti-gravity straining maneuver to open up their field of view and their vision. And by pushing, bearing downward, you can actually sort of prevent having a complete blackout. And for people who are small, I think small people, maybe women more than men, who have a shorter distance between the heart and the head, will have an easier time on these kinds of G-forces, withstanding these things. And the taller people might have some more difficulties, and they won't be able to be done without learning these anti-gravity straining maneuvers and practicing them in centrifuges. So this training, these studies that I've seen, essentially have said that they've explained to people what's going to be happening and what they need to do. And just even on an informational study in a centrifuge, where people are told what's going to be happening, they seem to perform better than those who haven't gotten any training. That's kind of logical, but they had less anxiety and they also understood what was going to be happening. But even those people who have been trained in terms of the information, understanding what's going to be happening, they were still unable to perform basic procedures. They were still unable to follow emergency procedures. There was still some anxiety. There were still some issues of people having to stop the centrifuge because they were feeling nauseous. And if all of these things are happening to you, you can imagine you're less likely to be able to accomplish your own mission of what you want to get out of those, that 4 minutes of weightlessness. So I find it really interesting about, that even with the data and the studies that Virgin Galactic, for example, have done, themselves, that they've come to the conclusion that yes, training, and the kind of training I'm talking about is in realistic, high G, low G environments, and mental training makes a lot of sense. They're still not going to be doing that, and I suspect they won't be until something happens, or until some movie star complains that they didn't get what they wanted to get out of their space flight. So I think they're just waiting, until then then the FAA will say, well, okay, this is what's going to happen. Everybody's going to have to do this from now on. But for now, they're not doing that kind of training. And just to point out the different types of people that will be, that are spaceflight participants, you have the classic space tourist and the classic space scientist. And they have different objectives of why they're going to be going into space. So the space tourist, essentially is going to to see what it feels like, to enhance their own sensory experience. Their focus, I would suspect, but not always, is going to be looking outside at Earth. But for, sometimes their focus might be inside if they want to be doing, making a rock video or doing somersaults. For them, it's a one-time, lifetime experience. Because people are not well trained, there's going to be a high potential for freeze or panic that goes on inside the spacecraft. And for them, it's all about maximizing the space to play. The space scientist is a little bit different. They are essentially being hired by, let's say, a university to go and maybe push a button, to start an experiment at the beginning of weightlessness, and then to push another button to end the experiment, or whatever, however they want to carry out their experiment. But they are on duty. They have a job to do, and they need to do it in the 4 minutes of weightlessness that they have, and they need, they want to get results. So it's very expensive to pay for these flights, and they can't mess it up. They're there to execute the experiment. Focus is very much on the inside of the spacecraft. They might have some multiple opportunities to go into space, but for them, they don't want any disturbance. They don't want people saying, "Oh, I'm flying around. Oh, sorry, that's my foot that accidentally kicked your experiment." They don't want that. They want to sort of ideally be in like their own little bubble that they can carry out their experiment, because that's what they're there to do. Now, unfortunately, both the space tourists and the space scientists will be being put together on these flights because, it's whenever they can fly and whenever they can fix schedules. So you can see the potential for clash on these two types of individuals that will be flying. And and they have very different types of needs. And the way you would be preparing a space tourist would also be slightly different about preparing a space scientist. And so when we do kind of a task breakdown in the left-hand column, there's a task breakdown of let's say for a Virgin Galactic flight, what we need to do, or what does the user, in this case a space tourist, what do they need to do? And on the right side, I'll explain that in a second, you have basically your ideal response for each of these different tasks. So this is very much a human factors engineering analysis to say, like, okay, what is the task, what needs to happen, and what are the skills that we need to do or execute in order to make sure that the mission is actually accomplished. So if we start from like the third number of starting, like getting strapped in to go and get taken, go for takeoff, then you are going to prepare yourself for the release of Virgin Galactic. You're going to have to sort of say, all right, I need to go and think about what's going to be happening now. High G launch happens to get launched 3.5 Gs straight up to 100 or a little bit less kilometers in space, 85 or 82. And then we go into the weightlessness period for 4 minutes. If we're space tourists, we take our seatbelt off, we fly around the cabin, we take pictures of outside, we take pictures of ourselves, we do our rock video or somersaults, bell rings, next step, get back into your seat, and then you are preparing for the reentry. Your seat's going to be turned 90 degrees, you're going to be on your back, and then you're going to get 6 Gs pushing down on your chest. You're going to have to do your certain breathing exercises to withstand that. And then you go and you land back at the spaceport. Now, on the right side, there's several mental and physical challenge skills that are needed in order to do the task correctly. So after, for example, you get strapped in, it's really important to sort of stay calm and present while you are getting ready and going up to, let's say, that 50,000 feet altitude point where you're going to be released. I think I can anticipate that there will be some people, that have a 45-minute wait before they go through, the exciting part of the Virgin Galactic slide, which will be, people will be freaking out in the, for the first 45 minutes, because it's not going to have, there's a long wait, and the anxiety is going to be building as that's happening before, and staying calm and being able to be present and not being in a complete freak out mode is something that they're going to need to deal with. Okay, and then when they release engines ignite, and you're going up to 3.5 Gs. The weight is being pushed down on you, the forces, and you're going to have to do your anti-gravity straining maneuver in order to stay, not have a blackout. Without this, you have a higher chance of getting tunnel vision. And let's say you did get a blackout. Essentially, what would happen is you don't know how long that blackout could last a minute or so. And then when you're coming to, you're already in your next step, which is like you need to stay calm and prepare for the weightlessness. So you need to sort of, not have a heart rate of going, oh my God, we just had this, incredible launch feeling. But we have to sort of get back to, all right, now if I'm going to, either execute my experiment or do my rock video or do my somersaults, I need to think about, okay, here's what I need to do. And if you're passed out and you're just recovering, you are not going to be able to get to the next step and execute that successfully. So it's not just a question of knowing what is going to happen, but you're going to have to learn skills as to how to instantly calm yourself if you need, in order to mentally sort of prepare yourself for the next stage. That takes training. The anti-gravity straining maneuver, which is learning how to breathe to keep the blood in your head. That takes training, and not just learning it on the ground, but then learning it in a centrifuge, because you can do it on the ground and you don't know if you're doing it well or not until you get in the centrifuge, because when you're in the centrifuge, that's when you'll be able to see, oh wait, I'm not doing it well, I'm starting to get tunnel vision, I need to do it better, and then you can get the feedback and work on that. But if you haven't practiced that in the centrifuge, you only know it when you're actually in the space plane itself. So essentially, I'm not going to go through all the details of this, but this is how I look at analyzing, like, what does somebody need to do, and what are the skills that are needed, both mentally and physically, that have to happen in order to successfully go to the next step. Because if you've skipped a step for whatever reason, the whole sequence is going to go and topple over, and that's when accidents and incidents and things like that will start to happen. So yeah, it's important. Just the mental training for going to space or inner space training really sort of helps people learn how to essentially stay calm despite the G-forces, the people around you, for everything that's happening. You have to learn how not only to sort of control your own reaction to what's happening, but realize there's 5 other people who may or not be trained, who can also get in your way. So it's not enough just to control your own reaction, but you're going to have to control your reaction relative to what somebody else who you don't necessarily know might be doing to you. And so these are important skills to learn ahead of time, so that when it's actually happening, when you get an accidental foot in your face, it's not going to upset you, that you can just go with it, not get angry, and still go back to enjoying the time or doing the task that you're trying to do. Preparing and understanding the psychological and emotional challenges of these different flight phases, that's kind of the last slide that I was just showing you. And understanding about your own personal mission. What do you want to accomplish in those 4 minutes, and how people all around you could be getting in the way of what you'd like to be doing, and how you can sort of, maximize your own performance, but also deal with other people who could be getting in the way. And, and also one of the things that tourists will be looking to do is create the preconditions for having the overview effect occur, which is this moment where people look out at space and then they feel connected to the Earth and to the universe and to everybody around them. In order to have this happen to them, you need to have your brain in a certain mindset in a kind of in a flow state, and you need to kind of learn how to train to get into a flow state ahead of time so that you can get yourself there, because things are going to be happening so quickly. It's even I even wondered myself how many people, even having created these conditions for the overview effect, will actually have that happen, because it's an act of grace if it happens. And, you know, if somebody's foot is in the way or something, you could be completely in the best frame of mind, and all of a sudden somebody knocks into you and kind of snaps you out of that moment. That would be a shame. But you can't make it happen. It has to be something that just will happen. But at least you can create the preconditions inside yourself, at least get yourself in the right frame of mind to have it happen. So that's what inner space training is about. And I guess lastly, I call it 3 minimum requirements. I mean, I've done a number of different training programs, like the helicopter ditching course and some spatial disorientation course, where I learned how sensitive I was to, spinning and things like that. But I think that is more useful if you're going to be spending longer time up in space, like on the ISS or doing one of these missions like Inspiration 4. But I really believe that the holy trinity of astronaut training, commercial astronaut training, starts with the mental training and then is underpinned by the centrifuge training and parabolic flights to learn those important skills of, being able to maneuver in 0G, to stay calm when, to execute your mission, and to be able to, understand, let's say, a centrifuge, how to keep the blood in your brain, and how to withstand 6 Gs on reentry, which is going to be feeling like an elephant is stepping on your chest. And these minimal elements, you can always add to it, with having other elements of testing your own skills and how well you dare to do difficult things like climbing mountains and things. But I really believe that these 3 types of training are sort of like underpinning what a commercial space flight is asking. And that's what I'm looking for. I'm looking for what are the tasks that we have, and what are the minimal sort of ways to optimize those tasks. And these 3 things are it, as far as I and people at Blue Abyss are concerned. So that's all I want to talk about right now. I'm happy to entertain any questions and get the discussion started.
Thank you, Dr. Mindy. From which locations are you training people?
So inner space training is a mobile training. I go to where my customers usually are, or sometimes I'll have, let's say, a training in Holland where local people can join. So it depends who's training and where they're coming from.
Okay, thank you. We have a question from Joanna Ocampo. She is a PhD student for molecular medicine, with the FAA having suggested guidelines and currently leaving the autonomy for the suborbital flight providers to make their measures requirements to fly. Her question is, are there protocols and medical procedures in place for a potential off-nominal event during the flight for the participants? Who would like to take this question?
I can answer a little bit. I mean, just from what I've seen from the American standards and the committees, these are the questions that they're starting to talk about. So minimal requirements for the crew, which are in general covering, I would say covering these things that were just mentioned. But for the spaceflight participants, there's not a lot of mandatory training that is required at this point. So
thank you, Dr. Mindy. Dr. Dorrit, would you like to add on here?
Yeah, I don't have any information about that. Maybe Dr. Rowena does.
Dr. Rowena?
From what I've read, I don't think at this stage anybody is planning to provide medical assistance during the flights. Blue Origin doesn't have any pilots at all. And Virgin Galactic has 2 pilots, but they'll be up in the cockpit. And at the present time, they're not planning to have a sort of flight attendant type person who could provide basic first aid. So this does seem to be a little bit of a hole in the model, because there certainly is the risk that some medical event will occur at some stage, and that there needs to be a contingency plan for that.
Thank you, Dr. Rovi. Now, last week we had a Space for Future episode with young Israeli analog. I think it was the world's first youth analog mission funded by the Israeli Space Agency. Do you think that the simulations here can make us advance faster in the investigation of the impact of space tourism on health? I'm referring to analog missions on Earth.
I can take that question. Yeah, analog testing is absolutely critical. NASA's been using that for decades. So not only to understand changes to the body, but also to have people experience the conditions of confinement. I think that the behavioral aspects, at least for being a confined space for long periods of time, are the things that we're most concerned about. So analog testing is absolutely critical for that. The Russians conducted an unprecedented first study of 520 days in confined space called the Mars 500 mission, where they put in 6 international crew members. I highly recommend that if people are interested in studying or understanding what happened over the course of the mission. NASA is now recruiting for a 1-year mission. 4 individuals will be enclosed in a space that's actually being 3D printed, which is pretty cool, at Johnson Space Center here in Houston for a period of 1 year. A lot of behavioral studies, food testing. That is the one thing that for long duration flights, food testing is absolutely essential, because we're concerned about food fatigue. On exploration missions, we're not going to be able to provide the resupply that they currently get on ISS. So, being able to live off of packaged foods for a long period of time is something of concern. In terms of short flights, some of the commercial capabilities, I think that G-forces in terms of centrifuge training is critical to understand what that feels like. I can tell you, I did some of those centrifuge testing. I think it was like it was the Virgin Galactic flight profile that I did a long time ago at the NASTAR Center. And it's one thing to just sit there and be a carrier, but if you're being asked to do a task in the middle of being centrifuged, that is a whole other level. So I think a lot of the providers are providing an autonomous experience where the passengers don't have to do anything. That's in a nominal situation, but if there is an off nominal event and you're pulling Gs, that is definitely a concern. In terms of analog testing for the short flights, other than the G-forces, I think what is really important is for people to experience the disconnect between the sensory inputs. In other words, it is very different than being motion sick on a roller coaster or motion sick in a car. Your visual system has inputs that are very out of whack with your balance system. And experiencing that, knowing what to expect is I think important. And there are ways to do that. You can sit in a rotating chair. There's actually a slow rotating room that you could sit in that will help prepare you for that. And in fact, the military had done that for many years with its pilots, because believe it or not, military pilots also have to deal with motion sickness as well as the G-forces. And so there are possibilities of getting you at least to know what that feels like, so that when you're taking that very expensive trip to space, you're not completely unprepared for those experiences. So yes, I think it's essential to have analog training.
Yeah, I just want to say I did that training in Brandeis University where they had spatial disorientation training. And I didn't think I had a problem until I did the training. And then I was like, oh, I guess I have a problem, because now I'm feeling miserable. And I have something called Sopite syndrome, which is a really nauseating thing to have and not a good thing as an astronaut trainer to have either. But there's ways now that I can counteract that and know about it ahead of time instead of learning about, oh, I have something while I'm up in space. So really essential to learn about these things.
Is also makes you sleepy as well.
Yep.
And very grumpy. So if you're in a confined space and you're feeling grumpy and sleepy and sick, you're not going to enjoy that experience. So completely agree with you, Mindy. Yeah.
Thank you. So this question is inspired by the Italian astronaut's tweet yesterday, Samantha Cristoforetti. She tweeted, "I didn't realize that there has never been a crew made solely of civilians. I'm curious, is it really so, or does civilian here have a different meaning than non-military police?" So the question is, what do you think about the concept civil passenger? Is it a good term to call the space tourist, or should we limit the use for those people traveling, being staff or of a space agency?
Yeah, the terminology is interesting. So what the industry has requested is that they're not passengers, they're not civilians, they are participants. And that is the requested word to be used, participants. And I think that suggests an action on their part. And I think that brings up the possibility of them engaging in research. To me, that is a really important contribution that these individuals can make. Some may choose not to, that's okay. If they choose later to share with the rest of us what that felt like, then I think that's a contribution in itself as well, to share their experiences on a holistic level. But a participant feels okay to me rather than passenger or civilian, because I think when you say civilian, it makes me think of military, which is not necessarily the case. I mean, NASA astronauts are certainly not military. So I think it'll be interesting to see how this plays out.
Thank you, Dr. Doroy. Dr. Rovina, would you like to add on here?
It's been, I guess, an interesting development in terms of the terminology, because a lot of people in the popular press and sort of the person on the street corner refers to space tourists. But if you do read all the formal documentation, it refers to commercial spaceflight rather than space tourism and commercial spaceflight participant, as Dr. Dorit just said. So I think in a sense there's sort of this disjoint between the public perception of what it is as some kind of joyride to space and the way that the industry itself is trying to position it. But it's nice that at least people who do participate will have the ability to participate in research which will make a meaningful difference and has a translational perspective as well.
Thank you. Mindy, do you want to add on?
Yeah, I just think it's a little bit confusing. I mean, Samantha's come from a military background, so for her it's clear, there's what I am and what I'm not. But there's a whole bunch of people who, also, let's say NASA astronauts, ESA astronauts that are they're not military, but they're working for, let's say, ESA or NASA. So what are those, like all people who are biologists or whatever, they're not military, but they are still astronauts. So I don't know, I find that's like another lens on top of everything, which is confusing, civilian or military, just to confuse everyone. But yeah, I mean, it's good that she starts to also, realize that there are going to be a bunch of people flying who are not trained individuals like someone from the military. Who's going to be going. But I think it's great that, now opportunities are opening up, for people, who don't have that kind of trained background.
Thank you. I think we covered all questions now. I want to thank all panelists for this amazing presentation, for Dr. Doré to get up at 5 a.m. and for Dr. Rowena to staying up late in Australia. So that's the beauty of Space for Women. We had Holly Ridings. She's from NASA. She said she once marked the most difficult part on a difficult mission is to have people to agree together. So it has been a beautiful journey to work with you today, and we hope we can collaborate in the future again. So thank you for your insightful questions, dear participants. We'll invite you for the next episode that's going to be on the 21st of August, Space Architecture, Holistic Design in Space Architecture and Interior Design. So stay tuned. Thank you for your attention, everyone.
Okay, bye everyone.
Hey, thank you so much. Bye.